In this video, I'm going to explain develop an ALP to find a largest number in an array of 32-bit numbers. So this is the demo I'm going to give you in Keil 4 for LPC 2148 microcontroller. So I'm opening the Keil tool. So you refer my old videos, that is a tutorial how to create a project. So in the same project, now actually you need to add new item, select ASM file, give the file name as a large 32-bit and save. So it is going to save it as largest 32-bit dot s. Automatically it will add the extension dot s. Okay. So here I am not going to add once again because it is already there. So you need to type here largest 32-bit and save it. And after that, double click it and you have to type this program. The first line is okay, ALP, assembly language program, find largest number in an array of 32-bit numbers. Now declare area. So area, the name of the area is largest. You can give any label. Okay, any name you can give for the area. So you can give largest num. You can give largest 32-bit num without space. You have to give comma. Then it is a code area. It is read only. So code is program memory, it is a read-only memory. Next is label entry. Move R5 with 0, 6. Okay. Move R5 is equal to 0, 6 because here 7 datas are given. Here 7 datas are given. So you have to load R5 with 6. That means first number, this number is compared with okay remaining 6. If you give 10 datas here, so you have to load with 9. Okay. Next, load R1 with the address of array. So this is the array declared as defined constant data. DCD means defined constant data. And 32-bit data are 0x400444, 0x2222, 0x1111, 0x333, 0x88, 8888, You can give whatever random data. Okay, all 32-bit should not be greater than 32-bit. So we have to give any data of your choice. Okay. Here in this is actually we are giving data in the read only. It is code memory, so you can read it. Okay. Now load R2. Okay. Load register R2. Load register R2. The first data. We already loaded R1 with the address of array. So what is the meaning of this one is load R2. Okay. Load R2 with address with the content of address. Content of address specified by okay R1. In R1 we have address of array location. So in that array location it will load the 32-bit data into the R2. Okay, after that, see, we observe this is very important, hash 4. This is actually to index. Okay, so it is going to increment. Okay, after the transfer R1 will be equal to R1 plus 4 because next byte is 32-bit means 4 bytes. So in order to fetch next, see, this is 44 is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte. All are actually present in the array memory. So in order to next time if you want to fetch, so initially R0 is pointed to the starting address of array. So next it should point to the 2222 here. So that's why hash 4 is given here. So you can refer what is post index index in ARM instruction set. So after transfer R1 is incremented by 4. That you can show in the simulation also. So next instruction is label loop load R4. Okay, load R4 with again same thing it is loaded with here. Okay, first data is loaded to R2. Okay, and it is incremented by 4. So now actually if I give same LDR R4 comma R1, it is actually fetching second data. It is actually fetching second data because R1 is incremented by 4. So you have to fetch second data. So here loading, okay, not next data actually, okay. So load next data, next 32-bit data into which register, register R4. Again, after that also, again R1 is incremented by R1 by 4, so that next time it will fetch third data. Okay, now first data is in R2, second data is in R4. Okay, now you have to compare which one is greater, whether R2 is greater or R4 is greater. Okay, it is going to perform R2 minus R4. It is going to perform R2 minus R4. So next we are having branch instruction. B stands for branch. Branch to the label loop, branch to the label group. Okay, or go to the loop 1, label loop 1. If first number is greater, that is R2 is greater. Okay, if R2 is greater, then otherwise if less, first number is less, then second number is actually greater, no? That second number you have to move it to R2. Second number you have to move it to R2. Here always in R2 register higher number will be there. Okay, if I are in R2 higher number will be there. Suppose if first number only in R2 number, what are the number is present in R2, that is only greater, no need to answer. So you have to skip these two lines. So next we have to subtract R5 because first number is compared with second number. Okay, so one comparison over. So remaining this comparison you have to do 1, 2, 3, 4, 5 remaining total 6 comparison, one comparison over. So remaining 5. So you have to decrement R5. So subtract R5 by 1. So and you have update S file, okay, update flag bits. So this is next you have to compare whether R5 is equal to 0 or not. So this instruction is not required because automatically when R5 becomes 0, immediately the flag is going to set. This is not required. You can check it out. With this also you can check it out. Without this also, this is not required actually because it is going to update the flag. Once it is 0, it is going to set the 0 flag. So branch to the loop, okay, branch to the label loop if 0 flag is not 1, okay. Branch, B stands for branch, branch to label loop. That loop label should be there in your program. You can see it is there in the line number 7. Branch to label loop if 0 flag not equal to 1. Okay, next load R4. So this will repeat every time first number R2 is compared with R4. First number is R2, second number is R4. Okay, if it is for R2 is higher, no need to exchange. Otherwise, you have to exchange. Okay, when it is doing stay up to third comparison, up to this comparison, R2 content is 444 only. No need to exchange. But fourth time comparison, okay, in R4 we have AAA. So that time this AAA is going to R2. So it is going to execute this move R2 comma R4. So this AAA will go to the R2. Always in R2 higher number will be there according to this program. You can write your own program. You can refer my one more program is there for LPC 1768, that is for EC students. So there you can refer one more program is there. Okay, whatever program you want, we want the answer. You should get largest number in the destination location. Okay. Similarly, after next comparison is AA with 88, no exchange. AA with 99, no exchange. So where you have to check the answer, you have to check the answer in R2. So R2 will be there. So you can also store the answer in the result. So you can write area name is, you can write its name as result. Okay. And it's a data area. In the data area, you can also do read as well as write also. So we are going to write that result here. So you can the result, I think I will write largest Okay, instead of result, here I'll write largest. Okay, largest DCD initially it is 0 and so this is a program. The output is you should get 0 A or A not 0. 0x means hexadecimal value. 8 A's should come in R2 register as well as in variable largest. So build target where one error largest. Yeah, here we have to get load R4 with address of result. Initially it was result was there in this place. So now you have to give largest. So it is you have to write case sensitive. You can write all small letters also. Again, LAR, LAR GEST, LAR GEST, multiply define symbol largest. It's giving some error here. Line number 21. Area result data read write memory largest. Here it is giving multi PCD 00. This error, you have to check it out. This is one. Now it is coming. I think result it should not give. Yeah. So the reason is why here I had given largest now. See here area for code memory I had given largest. So here you give largest number full name you give, and here you can give largest. Okay, then it will work because it is going to get confusion. That is a mistake I did. Don't give same name for the area label. Here I had given code area label as largest. Same largest I used here in the data. That's why it was giving some error. Now you can use very largest here. Here I had given now largest number. This is different. This is different. So now we are going to get. Okay. So here you can give only just result only. See, no errors. Earlier I had given largest here. Same largest I used as a label of code area. So that's why it's coming some error. So now no errors. So start debug. Okay, now let's execute step by step. Click this button, step over. Initially R5 is equal to 6. Then see as address. We don't know where that these datas. Okay, these datas are loaded. So if you want to see, you can see here. Load R1 with address of array. That address is what? 00030. So in the memory, I think you can type 0000030. You can see it's coming 44221133AA88. Okay, is a code memory. In the code memory, how to get the address? You just give load R1 is equal to will give the address. Okay, address. So if you in the memory window open the memory window 1 and type that whatever address is coming in R1, you can see the data also. So in this data, AA is the largest. So that is the expected output you should get in the R2 register. So now get the first data. Load R2 first data. First data is 444. See once it is red, it is coming in red color. Okay. After that, okay, R1 should be incremented by 4. Initially, it was 30. No, Now you can see R1 is 34. It is incremented by 4. Again, you have to load R4. Next, we are loading R4 with the content present in 34. In 34, we have this 2222. You can see here, you can drag this and you can check every 4 bytes, say 30, 31, 32, 33. Actually, lower byte is 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. After 38, actually 3A, 3B, next to 3C, like that. Okay, this is hexadecimal count. Okay, now it is going to load 31, 34. That's 22 will come to R4. You can see here in the R4 before execution, it is 000. Now 222 is coming again. It is post increment. Okay, this is R1 is incremented by 4. You can see the value is 38. Okay, the value is 38. If you move the pointer here, it will show what is the current value of R1. And you can also observe in the register. So now it will compare which two register. First number location, first number is there in R2, second number is in R4. So we are comparing R2 and R4. After that, you can see current program status register. Okay, whether carry is there or not, you can check it out. Okay, compare R2, R4. If first number is high, you should go to the loop 1. So let us do exchange will take place or not. Actually, see this pointer. Okay, see first number is higher. In R2 we have 444. Second number is 222. If branch if higher, okay, branch higher to label loop. So no need to transfer smaller number to R2. And here subtract R5 by 1. Okay, decrement counter means R5 is equal to R5 minus 1. R5 is equal to R5 minus 1. Is decremented by 1. So 5 becomes, actually, sorry, 5. This is initially it is 6, no? It becomes now 4. So 5. Next, if it is not equal, if zero flag is not equal to 1, zero flag, you check it out. Zero flag is 0. If it is not equal to 0, branch to label loop. So this is the loop. And again, it will load next to data. Next data, R1 is now how much? 38. In 38, you see the memory window. 38, we have 111. Still, it is in gray color. It is not. Once the data is read from the memory, it's coming red color. So now actually 111 will read and it becomes red color. See the memory, it is coming in red, and this data is next data is coming in R4. Now actually R2 is 444. It is compared with 111. Again, first number is higher, so it will jump to the loop 1, and it will subtract R5 once again by 1. Okay, so it is not equal to 0. That flag you check, not equal to 1. So go back. Again, take next data, that is 333. Compare 44 with 333. Again, first number is greater. Skip. Decrement R5. Not Z flag is not equal to 1. So loop. So now next data A is taken to the R4. Now actually exchange will take place. R4 will be moved to R2. Okay, it is moved. Will move now. So yeah, and R2 highest number came. Again subtract R5 not equal to 1. So load next data, that is 888. Now no exchange. Next load 9. No exchange. Okay, now R2 becomes 0. See here, sorry, in R5 count is there, no counter. Now R5 is 1. After decrement, Z flag is 1. If z flag is 1, if it is not equal to 1, go to the label loop. Now it will execute next instruction. So we are loading R4 with address of the variable largest, which is declared in the data area. So it will load address. What is the address? You set it out. Load R4. In R4, what is the address coming? 0x4000. So in the memory window, you open one more memory window. You open only one, no? So open one more is there. 4 up to 4 you can open. In the memory window 2, you type 0x4000. And by default, so one more 0 to type. Left side, if you're coming at 10, one more you put it. So this is by default unsigned char will be there. That you change it to long. After that, okay, this store R2. R2, what is there? Highest number. AAA is it. That AAA will move to this. So this is the answer. We are getting largest number here. Okay. In the given data, largest number is AAA that is coming here. Okay. And you can convert same program to store. Okay. To find smallest also largest comma smallest. So you can convert the same program for smallest also. So for that, just change B high to B. Okay. So stop debug. If you want to modify, you have to stop the debug and you have to, instead of high, you change it to low. Okay. Here the number, first number is higher now. Instead of higher, you type now lower. First number is lower, then now wait start debug. Then I will go fast. Okay. First it will compare. See, first data is there in this. It will iterate actually 4 4 and 2 2. First number is actually not lower, so it is going to exchange. Smaller number 2 2 will come to the R2. Say 2 2 2 coming to the R2. Next it will compare 2 2 2 with 1 1 1. Okay. Again 1 1 is the smallest number, so 1 1 will exchange. It will come to the R2. It came to R2. After that 1 1 1 is compared with 3 3 3. So no exchange. You have to skip. Next 1 1 is compared with AAA. Again no change. Skip. Next 1 1 is compared with 8 8 8. Again no change. Skip. After the once R2 becomes R5 counter. If R5 counter becomes 0, okay, R5 becomes 0, you can check Z flag is 1. And Z flag is not equal, it will go to the label loop. Now it will come out. Now actually here instead of largest, actually you have to type what? Smallest. Right? I did not change that. So I'll change so that you will understand. Now actually title also I have to change for smallest. And here smallest. Can observe here always in R2 list number 1 on will be there. For the execution of task, okay. Now it is going to execute store R2 to the smallest location. Smallest location address is same 4000. You can see the address in R4. Load R4 address of smallest. Address of smallest is 0x4 followed by 7 zeros. So it is 0 now. Now it is still it is not executed. The pointer is here. So execute step over. So it came here. The smallest number came to this location. You can also observe smallest number in R2 also. Okay. So like this you can change the data to whatever data you want. In the first program, you are going to get largest number. In this, if you change B high to B low, smallest number will come in this location. Thank you.